So the vector v has an initial point, P, and a terminal point, Q. Find the position vector in the form v equal to ai plus bj. So a vector has magnitude and direction, so it's not just a line or a arrow. It actually means all kinds of things, and you can actually, and in physics they use it in terms of force, or to determine the direction of a force given its magnitude, so you can have the angles and etc. Or if you have like opposing forces, you would use vectors to denote this. But usually they start off with having you find the vector. So we're going to do two-dimensional vectors. So here are 2 points. So to find the vector that goes through these points, this is what you do. So the notation, put a little hat on there. V is equal to PQ, which is going to be basically the last point minus the first point. And you use these kind of symbols for the vector. So I'm going to take the x point, 5 minus 3, and then put a 2 minus 3. So that will give us 2 comma negative 1. So this would be the one way to write vector notation. Another way they might write it is using the ij. So this would be 2i minus 1j. And this is different from the I of imaginary numbers. This is the I component for the vector, meaning the x part and the y part. Okay, but if you write it this way, then I know you mean a vector, and you don't have to write ij. That's up to you how you want to write it, it doesn't matter. Okay. Visually, this would be see 1, 2, negative 1. It would be this arrow, this vector. So they'll ask you, eventually we'll get to it, but they'll ask you what is the magnitude of the vector, meaning its length. If it's a general vector, then it means length. But if it represents something in physics, magnitude could be like the amount of force, weight, etc. Anyway, let's keep on going. Let's talk about how to find magnitude. So they'll use this notation for magnitude. It's kind of like an absolute value bar, but they have 2 of them for V. So find the magnitude of V. Okay. Let me see what's a good V here. So V will be negative 5i plus 12j. So the formula for magnitude is basically just the distance formula, which we've done quite a bit in this class. you square the A component and the B component, A1, B1, which should give us our magnitude, okay? Where V is equal to some A1 value B1. So for our case, the magnitude of V will equal the negative 5 squared plus the 12 squared, which will be square root of 169, which equals 13. So that's all you have to do for magnitude. So the first few questions just ask you, okay, what is the vector through 2 points, which is right here. Then they'll ask, what is the magnitude of the vector? They might have you find the vector first, and then give them the magnitude. You guys have any questions on 1 or 2? After that, they're going to have you do get some basic algebra with vectors. So example 3 will be find the magnitude, find the quantity of 7i minus, so V would be 7i minus 9j, and the W vector will be negative 6i plus 4j. Then they'll ask you to find V minus, no, sorry, it's a different question. They're going to ask for find.
What does it say there? Vector 7i minus 9j. And then after that, what does it say?
The W vector is negative 6i plus 4j.
Okay, thank you.
Mm-hmm. So they're going to just have you find 6v plus 7w. So just scale the vectors by 6 and 7 and add them together. So this would simply be 6 times, let me write it. This pen's too light. 7i minus 9j plus 7 times negative 6i plus 4j. So that'll be 42i minus, 6 times 9, so it's going to be what? 54?
63. Yep.
63?
No, 54, I think.
Yeah, that's right. Okay. Thanks. So then 7 times 6. Okay. 7 times 4. So all we're going to do now is combine the like terms. Nothing else to do here, but looks like these will cancel, right? Then negative 54 plus 28 looks like about almost half. So we have 0i minus 26j. So you can write it either way. You don't have to write the 0i. If you don't write it, it's implied that there is no I component. But if you write it this way, it's more clear. But it doesn't matter to me, however you want to do it. Okay. So find the magnitude of v minus w if v is negative 3i plus 2j and w is negative 6i plus 5j. So we're going to have to find the magnitude of the difference. So just subtract them first and then use the distance formula. So first find what is v minus w, right? So I'm going to go ahead and put them in parentheses just to be careful. This would be negative 6i plus 5j. So negative 3i plus 2j plus 6i minus 5j. Just distribute our negative. That will give us 3i minus 3j. So once you have your vector, now you can find the magnitude. So that will simply be the square root of the 3 squared plus the negative 3 squared, which will be square root of 18, which is 3 root 2. Okay. So another one. On this one, we're going to find the magnitude of them separately instead of at the same time, and then subtract, just to show you that it's not the same, right? If I find the magnitudes first and then subtract them, that will not be the same as this difference magnitude. Okay. So this would be well, let's go ahead and use the same vectors for fun. So let's find the magnitude of them separately. So this will be, again, a 3 squared, negative 3 squared, plus a 2 squared. And then the magnitude of w that will be -6 squared plus 5 squared. So this will be 9 plus 4, right? This will be 36 plus 25. It's pretty much all we can really do, because these are not the same, right? We have radicals that are different. You can't subtract them. So when they ask us to find the magnitudes and then subtract it, or the difference of the two magnitudes, is basically going to be root 13 minus root 61. That's all you can do. So you see how they're not the same, right? Okay. Anyway, that's all there is for these type. So if you see them, ask it separately or together. Just remember it's not the same. That's all I want you to remember from these two examples, other than knowing how to find the magnitudes, but that was the point of doing those two. Okay. You guys have any questions so far?
No, sir.
Okay, so now let's talk about unit vector. This comes up a lot in many different classes or science classes. So find the unit vector in the same direction as v. So basically what you do, basically what you're doing here is you have a vector and you want to kind of like minimize it into just a unit of 1, but still go in the same direction. So like for example, visually, right? Let's say you had a really long vector, root 65, and you're like, you know what, I want to shrink that down and only deal with a unit, right? So you would basically have the same direction, but only be length of 1. That's the whole point of the unit vector, because you can still do a lot of operations with this, or make conclusions based off that without having to deal with this giant vector. Okay, so that's where we're headed. Here's v. So they want us to find the unit vector of 4i minus 7j. So unit vector, we're going to use the symbol u, will simply be the original vector divided by its own magnitude. So you're basically dividing out its own length. That way it won't be big anymore. So it'll be like the same vector just shrunken down, okay, scaled down to 1. They're just not equal. They are similar. So we got to find the magnitude, right? That's the first thing. So the magnitude will be the square root of 4 squared plus -7 squared. That will be 16 plus 49, right? Which is that a perfect square? 49? No, close. Root 65. Okay, so my magnitude is 65 and I want to get rid of it. So to create u, what I do is take the original vector and divide it by its magnitude. right? You divide by its length. That's all I mean. Also, all that means magnitude. Okay, so then here we go. You take the v, 4i minus 7j, divide by root 65. So that would give us 4 over root 65 I minus 7j over root 65. And then we can rationalize it, because that looks kind of ugly, into 4 root 65 over 65 I minus 7 root 65 j over 65. Okay. So this would be the unit vector. So if you were to, I guess, graph these, you'd have one that looks, it'd be longer, but then you have a unit version of this. Okay. So this would be the unit 1 vector. Okay. And when I say unit vector, I mean that the magnitude of this guy will be 1. So if you were to use a formula again on u, you're going to get 1 because you've already divided out the length. Okay. Let's do a couple more and then we'll move on to something else. Write the vector v.
Can you move the paper down, please?
Yeah, there you go. In the form ai plus bj given given its magnitude and angle, which we'll call alpha, it makes with the positive x-axis okay, so here is the magnitude v, 20. Angle alpha will be 120 degrees. So there's a formula where you can decompose your vectors into sine and cosine. So v can be written as the magnitude times cosine alpha plus sine, oops, forgot something. Cosine alpha times I plus sine alpha j. Okay, so you can use this given these two pieces of information to find what the vector v is. So we just plug it in, we'll have 20 times cosine of 120 degrees I plus sine of 120 degrees j. So that would give us our vector. Cosine of 120, that's what, negative half, right? Times I plus square root 3 over 2j. So that would give us a negative 10i plus 10 root 3j. which is in vector form would be -10, comma 10 root 3. But either of these are fine. All right, so this is called decomposing. So if you're given this, you can also decompose it into sine and cosine, which is helpful like in physics when you need your when you want to find the x component force or the y component force. Like if you're pushing something at an angle and you want to know how much force is coming from the vertical or horizontal directions, they can help you out by decomposing. Okay. All right. So now let's do an example where we find the actual direction given a vector. Okay. Find the direction, angle, alpha of v, the vector v, 4i minus 4j. All right, so similar to what we did before, we can use tangent to help us out. So tangent of alpha is equal to y over x. So that means that tangent would be equal to -4 over 4, which would be -1, right? So solve for alpha using your inverse tan. Alpha would be tangent inverse or arctan of -1. Now the only question is, if we punch this into our calculator, what are we going to get? Are we going to get the one we want, or are we going to get something else? Right, so here. Remember, the range of tangent inverse is going to be -45 to 45. Or I'm sorry, -90 to 90. So to get the one we wanted, we would add 360 to this. So it should be 315. So alpha is equal to -45, so add 360, giving us 315 degrees. So our vector is right here somewhere. -45 is this way, because that's how the inverse tan works, right? That's how it's defined. But the other direction, this way, is 315. Okay, do you have any questions on 10.4?
No, not right now.
Okay. Let's move on to vectors in space. Or sorry, dot product. Spaces later. Okay. Oops. What was it doing? Oh, here it is. Okay. So the dot product is almost like I guess it's the closest thing that we have to multiplication of two vectors. It can tell you a lot of different things. But first, let's just learn how to do it. So given two vectors, 2i plus 3j and w equal to 3i minus 2j Part A will find the dot product of v dot w. So all you have to do is multiply the i's together and the j's together and add them together, and you're going to end up with a constant. So whenever you do a dot product, you're going to have a number, not a vector. Okay, so if you still have a vector, then that you did something really incorrect. So v dot w, it's not necessarily a times, right? They call it dot product. You're going to take the i's plus the j's multiplied together, giving you some constant. So this would be 6 minus 6, which is 0. So v dot w is going to be 0. Okay? So that's all it is. When you multiply v and w, you only multiply the matching pairs. And then you sum up the rest. You add them together. Okay? Okay. Part B is find. So they're going to ask you in this section to find the angle between two vectors. So not just the angle or direction of one vector. So this is different. To find the angle between v and w. So the definition that we can use to help us out is cosine theta is equal to this formula here. So the vector dot product of v and w divided by their respective magnitudes. Theta would equal just the inverse of this, right? So whenever they ask you the angle between two vectors, use this formula here. Okay. Now, if the dot product is 0, like this one, that means that this top part would be 0, right? Meaning the whole thing is 0. So cosine inverse of a big old 0 right here, right? What is that going to be? Yeah, so when you get a dot product of 0, that implies that the two vectors are orthogonal to each other. They are perpendicular. They are at 90 degrees from each other, okay? So right away, when you do a dot product and you see this, you can say, you know what, those vectors are at a right angle automatically. You don't really have to do all this, but if you do, you'll end up with a 0 anyway. So you're going to get there regardless. And so theta would be cosine inverse of 0, which is 90 for part B. You guys see why that's a 0?
Yeah.
Okay, I'm gonna go to the next question. Unless you guys have some you guys have any question on this, let me know.
Okay.
All right. So given V, so number 2 then, equal to square root 3i minus j, and W equal to negative I minus j. We'll do it one more time. Part A, find V dot W. Part B, find the angle between V and W. Okay. So same thing as before, right? So V dot W means we just multiply the i's together and then add the j's together. So that will be a negative root 3 plus 1. Nothing else I can do there. Okay. Now, angle between will simply be theta equal to cosine inverse of all this stuff, V dot W over the magnitude of V and the magnitude of W. So we don't have the magnitude, so we're going to have to find those first, right? So the magnitude of V would be equal to the square root of root 3 squared plus negative 1 squared, which will be 2. Magnitude of W would be negative 1 squared plus negative 1 squared, which will be root 2. So now we got the pieces that we need. So theta will be cosine inverse of the dot product, which we did up here, negative root 3 plus 1, divided by 2 times root 2. So I'm just going to punch that whole thing into the calculator. It's just, I don't want to deal with it. The second, cosine inverse, I advise you put a fraction in there, and if you can't, put correct parentheses. So negative root 3 plus 1, 2 times root 2, 105. So that would be 105 degrees. So the two vectors are separated by 105 degrees. They will also ask you if the two vectors are parallel, orthogonal, or neither. So part C, are these vectors orthogonal, parallel, or neither? So if they're parallel, then they're right on top of each other, meaning this angle here would be 0. If this angle is 90, then they are orthogonal, or in other words, perpendicular. If it's neither of those, well, you say neither. Angle between is 105 degrees, so neither. Okay. Is there any questions so far?
How did you do the fraction on the calculator?
Do you have one of these type? Or
Yes.
Okay, so if you want to use the fraction button, let me show you. Just hit alpha. Oops, sorry. Yeah, here it is. Press alpha and then the y equals button.
Okay, thank you.
Then they have different kinds. You can even convert a fraction to whatever. Okay. Let's do example 3. So here, so the first few, pretty much most of the problems will be just for section 10.5. You're gonna say do the dot product of this, find the angle between, and then they'll ask you parallel, orthogonal, or neither. And then the last questions that you'll see is a decomposition. So they're gonna ask you to decompose some vector v into two different vectors, v1 and v2. Where v1 is parallel to some vector w, and v2 is orthogonal. Okay, so what they're going to do is give you v and w, and they want you to decompose them so that this is true. Okay, so this is what the question will give you. A v and a w So the formula we need to decompose, so v1 in this case is defined as v dot w over the magnitude of w, then a dot product of w. Actually, sorry, that would just be a regular product because this would become a constant multiplied on w. v2 is then v minus v1. So you need to find these guys. given V and W. That's what they're asking for. Okay. So here we go. So we need the dot product and we need the magnitude. So let's go ahead and find that stuff first. So V dot W is equal to 12 times -1 plus 4 times 1, which will be -12 plus 4, -8. We need the magnitude of W, which will be 1 squared plus 1 squared. That's all we need. So this is find V1. V1 is equal to, this is like my side work here. V1 is a dot product over the magnitude dotted with W. So that would be -8 on top, right? Divided by √2 times W. Okay, so that would give us negative, actually positive. That would be 8I over √2 minus 8J over √2. Let me double check something here. Oh, shoot. The formula is supposed to be squared right here. Sorry about that. See what has a magnitude? That should be squared. So this needs to be squared, which would get rid of our root. So the only difference is put a square on these guys, and we need to change this to a 2. That's about it. So V1 will be 4I minus 4I. And then V2 is simply the original minus the V1 that you found. So the original is, I'll do it down here, 12I plus 4J minus the one we found, 4I minus 4J. Yeah. Which will give us 8I plus 0. Actually, plus plus, minus minus, yeah. 8I, 8J. So this should be the vector that is parallel to W. I'm sorry, V2 is orthogonal to, what was the question? To W, I forgot to say that. Orthogonal to W, and V1 is parallel to W. There we go. Do you have any questions on this, these ideas? All right, guys, we'll finish, I think we'll probably finish chapter 10 next time, and then maybe review Still trying to decide on that exam date because this is week 13. Next week, yeah. So I don't think so we'll probably finish 10 on Monday, and then maybe begin the review, and probably finish the review on the 25th. But I will not have the test on the 30th. We'll most likely have it on the 2nd. I don't want to rush through those last two sections. There's a lot of stuff.
So you're moving our exam for the 2nd?
Yeah, I think that'd be better because, I mean, it'll be during that whole week. So anytime during that week. So I think it'll close on the 6th, but I would prefer you take it sometime after the 2nd. But after that is the finals week.
Okay, I was gonna ask, so is that our final, or we're still gonna have another test on the 7th?
Yeah, you also have another exam, the final exam. I'm gonna let you take it anytime during the week of the 7th.
Okay.
But I'm gonna review on the 7th.
Okay.
If anybody has a final during that time, please let me know. But we'll see how it goes. It's kind of my plan at the moment. So finish 10, 23rd, review 25th. Maybe start reviewing for the final on the 30th and the 2nd, and you can take those exams during those 2 weeks.
All right.
You guys have any other questions?
Are you still going to drop